Hello, everybody. Virtually, my name is Chen Admati, and I'm from Intel. And today I'm going to share with you a session that aims to provide an introduction to AI and share with you, hopefully, a practical overview on how potentially you can start apply AI in your organization and hopefully see a lot of value out of it. My name is Chen Admati, and I work at Intel, and I'm part of Intel's global internal AI unit. And our role at Intel is to transform the critical work and critical processes that Intel applies in order to optimize them using AI. We are working across the country in the design, manufacturing, sales and marketing, supply chain, and many other areas with the objective to be able to run the critical processes using AI and eliminate some of that are bounded today. And in this presentation, it was developed based on an experience of over 10 years of building AI software and AI applications. Give you some ideas, hopefully, on how AI can generate value to the company, to an enterprise, in the magnitude of hundreds of millions of dollars each year, and hopefully that can give you some idea you can apply AI in your organization. So what we will cover today in the next 45 minutes, I will go over some of the key terminology of artificial intelligence. Follow that, I will talk briefly in high level how machine learning algorithm actually works and what we should make sure that we have at hand in order to build a successful machine learning algorithm or any. I will share a few applications examples from the work that we have been doing at Intel, and hopefully that can be relevant to your organization as well. And last but not least, I will talk about a few best practices that we have developed over the years in order to increase the likelihood to run a successful AI project. We will get going, and we will start with basic AI terminology. So there are a lot of different terms. I'm sure that you've heard some of them, and sometimes different terms are being used interchangeably. So I want to start with a few minutes to talk about some of the basic terminology and try to get some understanding around them. So let's start with artificial intelligence. When we're talking about artificial intelligence, at the end of the day, we're trying to describe or to exhibit by machine human intelligence. It's a relatively broad term, but at the end of the day, what we are referring to any techniques that enable a computer to mimic human intelligence by being able to sense, get an input, understand what this input means, decide on what is the best action to perform based on what understood, and over time be able to improve and adapt based on the feedback on what actually happened. So this is the general term, and in artificial intelligence there is a subset or an approach that is called machine learning, and these are algorithms that are actually helping us to achieve artificial intelligence. What is unique about those algorithms is that it includes complex statistical techniques that enables machine to improve based on past experience. And when we're saying experience, we are talking about obviously data, and we will talk a lot about data today and what does it mean and what kind of data we need in order to be able to use machine learning. Neural networks are actually a subset, one type of machine learning algorithms. And the reason that I'm calling them out is that they're relatively unique because they are trying to mimic and they were built in order to mimic the way that the human brain are working. And for those of you who have heard the term deep learning, this is actually an advanced class of neural network. Those algorithms are actually using multiple layers of neural networks. And in the last few years, they have outperformed humans in specific tasks. When we're talking about videos or speech, these are data types that are very good when we are talking about deep learning. The most common example is when you are uploading your pictures to Facebook, and immediately there is a face recognition, and Facebook is offering you to tag your friend or your relative based on the identification of the person in that picture. So this is one example for a deep learning algorithm which is outperformed when we're talking about images, text, or voice. The data science is the practice of implementing artificial intelligence, machine learning, deep learning. So all of it together is called data science, and the data scientist is the practitioners that is performing the data science. So when looking on different organizations, we see different usages of data. And I want to call out the different maturity levels. And again, we are looking at, it doesn't mean it's always sequential, but in many organizations, we do see it as an evolvement of the maturity of how organizations are leveraging data. When starting, a lot of organizations are starting to collect the data and then to perform what we call descriptive or diagnostic analytics, which is mainly looking on historical data and trying to understand what have happened and why certain things had happened. The next level is what we call advanced analytics, is where we are trying to not only understand what have happened, but what will happen in the future. And if if we know to predict what will happen in the future, how we can, for example, decide on what is the next best step. When we're talking about artificial intelligence applications or capabilities, we are not just have the ability to predict what will happen and what is the next best action, but we actually have a system or an application that knows to apply those actions in an autonomous way, meaning that we can operate there. We have a capability that in real time have the ability to predict what is going to happen, what is the next step, or what is the action that needs to be performed in order to optimize a certain strategy, and can do that in a very high scale, and we will talk about that and see a few examples later on the presentation. The last term that I want to discuss today is big data. And when we're saying big data, we are actually referring to a set of technologies that enable us to, first of all, store and process different types of data. And actually, when we the most intuitive thing is to take, when we're saying big data, is to think on the size of the data, but it's not the only parameter that defines big data. There are what we call the 5 V's. that describe different characteristics of data, that all of them are actually falling into the category of big data. So the most obvious one is the volume, how much data is collected, or what is the size of the data. The second thing is velocity, is how much it takes us to collect new sets of data. There are cases where the data is being generated in a very high pace, and we have a huge amount of data that is being generated in a very short time period. The third one is variety, the types of the data. It could be structured data, it could be text, audio, images, video. So all of those are considered to be big data. The next one is talking about the quality of the data. It doesn't only important that we have tons of data. We need to data that is actually present accurately the reality that we are trying to mimic using software. So veracity is talking about the quality, and last but not least, the value. What can be generated using that data. In many cases, we see in organizations that we have tons of data, but unfortunately, we cannot do anything with that data. So the last V is talking about the value. So all of that together talks about the characteristics of big data. And of course, AI is very applicable when we have big data, because a lot of the applications are actually requiring these types of data. Moving on. In this section, I would like to talk about how machine learning algorithms are actually. Don't be panicked. I'm not going to talk about any technical, boring details, but I do want to talk about the key components of machine learning algorithms, because that's important to understand when we later on talk about use cases and how to avoid some common pitfalls. Sorry. Okay. So machine learning algorithms actually includes three main steps. The first one is starting with collecting the data as much as possible and all of the data that is required. The second step is to train the algorithm. And when we're saying train, we are talking about the ability to generalize the view of the problem, and we will talk about what does it mean in a few foils. The last one is the inference, and that refers to the ability to apply the model that we have built during the training phase and being able to conclude some predictions on new data that the algorithm has not seen before. So let's talk about in more details on each of those steps. Everything starts with the data. This is the fundamental oil, and this is, I would say, the most important part in order to be able to successfully build an AI application. When we're talking about the data, first of all, we need to make sure that we have sufficient amount of data. It doesn't mean that we have tons of data necessarily, but it means that we can build or train a model on top of that data that will be able to generalize the problem and be able to identify all of the cases in which if we will be using humans, all of the knowledge that exists in a human mind in order to be able to address all possible scenarios. Beyond that, we need to make sure, beyond the quantity, we need to make sure that we have the right level of quality. This is critical. There is a statement in this domain calling garbage in, garbage out. If the data doesn't represent or relevant to the problem that we are trying to solve, meaning that the data doesn't tell the story of how the business processes actually work or how decisions are being made. It doesn't matter how sophisticated the machine learning algorithm will be or how what a level of expertise the data scientist will have. It will not be able to perform the task that we are aiming to get. So the data is the first step, and in every project that we would like to apply, we need to make sure that the data is actually applying and represent the world and the usage that we would like to achieve. The next steps is generalization. When the goal is to be able to predict on data that the algorithm have not seen before. So what we are doing, we are actually learning a model, which is a statistical model that is being built using historical data, which is called the training phase. The idea is to learn from historical data and to generate a model that is general enough in order to handle combination it haven't seen before. However, it needs to be just specific enough so it will be able to accurately be able to perform with more subtle patterns that have not been seen in the past. What we need to be careful is we cannot be too specific on historical data because then it will be too specific to the examples that the model have seen on the historical data and won't be able to handle properly examples that have not been seen so far. So we need to find the balance between being too general, meaning that the training model is too and will not be accurate enough, and being able to specific to the examples that we have seen on the historical data. So when unseen data will arrive, it won't be able to predict accurately. And this is the art of the data science to generate a model that is robust enough in order to meet those two trade-offs. When we're talking about the training phase, it can take between minutes to weeks. It really depends on the size of the data and how complex the algorithm is, and of course, the computational power we have at our disposal. We usually trying to, it's not a one-time task, meaning that from time to time we will need to retrain the model in order to make sure that the accuracy level is maintaining over time as new data is coming to the system, and we need to reflect that in the generalization of our model. Last but not least, something to highlight is when we're talking about training, or learning, we're not talking about memorizing, meaning that we don't have a closed set of rules that can be addressed every example or patterns otherwise it will be memorizing and not learning. Every machine learning algorithm will have some level of mistake. The intent is to minimize the places where the algorithm is wrong, and to maximize the accuracy of the model based on the data that we have at our hand. The last step is the inference. The inference, as I said, is applying the learned model on the unseen data. It's usually a very short task. It could be happening either in the data center, in the cloud, or actually at the end device. And we will see a few examples for that. And what is very important is that we are continuously monitor the quality of our inference to make sure that the accuracy level remains intact. And once we are identifying that there is a degradation in the quality of the model or in the ability to accurately predict what is going to happen, then we will trigger to retrain the model and to generate a new learning model that can be applied during the inference step. So these were the 3 steps, and I want to start with an example for a use case that we've implemented many years ago at Intel. And the idea is to be able to identify some fraud or errorless activity in our sales and marketing domain. So as a background, Intel is reimbursing its partners whenever they are doing some advertisement and they are calling out the Intel brand. So there are specific guidelines on what the advertisement should include in order for the partner to be entitled for the reimbursement from Intel. And in order to get those reimbursements, they are actually submitting claims. And there are errors, or some of them are done by mistake, some of them perhaps being done intentionally. But Intel is auditing not all of those claims, but selectively, in order to determine if that partner needs to be reimbursed or not. And the idea is and the question is how we can better select the claims that will be audited in order to maximize first of all, the error, or to minimize the errors for a fraudulent activity that is not being captured by Intel, and also to reduce the burden for our partners that need to submit additional information in case that they're being audited. So what we have done is we looked at all of the data that we had on our disposal. So the data that we had included historical claims that were submitted to Intel. And out of those claims, we looked on the ones that were audited, meaning that we had additional information on those claims. And for each claim that was audited, we know if that was found to be a compliant or non-compliant. So based on that data, we have built a prediction model. The prediction model we took all of those, the data that I described, and we cleaned the data, we generated different features, we did some transformation on the data, and applied different algorithms on that data. Once the algorithm completed the processing phase, we evaluate the quality of the algorithm, KPIs, key performance indicators that we defined in advance, and we evaluated based on applying the machine learning algorithms on unseen data, meaning some subset of the data that we put it aside. And we actually know if they were found as non-compliant or compliant. And then we could evaluate what is the quality of the algorithm that we have at our hand. What is, from how many, out of the ones that were found compliant, how much time, in how many cases the algorithm actually predict that accurately. And same goes to claims that were found as fraudulent, and how many times the algorithm actually identified those as such. Only once we built an algorithm that actually satisfied the quality evaluation criteria that we defined, then we deployed it in production, and this is the inference phase, meaning that we have a new claim that a customer or a partner is submitting. Then the model is being inquired and recommending whether it would be potentially be non-compliant, and then it will be sent to an audit. Or if it's found as most likely to be compliant, then it's automatically being reimbursed. The solution that you can see here was actually had an ROI of millions of dollars each year, and also helping, of course, Intel reputation, because it generates less burden of our partners, and being able to properly more select the ones that have a very high likelihood for errors or for fraudulent activity. Okay, so with that said, this was the first out of a few more that I would like to share with you today on actual implementations that we have built at Intel over the years. Example that I have here is coming from our manufacturing domain. After the chips, the CPUs are being manufactured in our factories, the last step is to test them, and this is a very complex phase where each unit, and we talk about millions of units that are in the manufacturing line each minute, is being tested, and there are a lot of different tests that each unit needs to be tested in order to make sure, obviously, that we are meeting the very strict quality characteristics that we need to meet as our commitment to our customers. So before implementing the AI algorithm, so each unit was going through the exact same task in a sequential order. Using a machine learning algorithms, we have the ability to create an adaptive scheme, meaning that based on all of the information that we have gathered on a certain unit, we know to say what is the likelihood for a defect, or what are the places where we need to test. So for each unit, we can either say, okay, this unit is getting a free path, and we can eliminate or skip some of the phases, versus another unit that perhaps the likelihood for a defect is high, and then we will test and perform all of the tests. The impact on that is huge because, first of all, we are minimizing the test time, and every unit that is being released is actually shipped to customers. So we have the ability to ship more units. And obviously, there is not only that, but also we have the ability to improve quality because we know for each unit exactly which test needs to be performed. And as a result, we can improve the quality. And this is a solution that is generating hundreds of millions of dollars for Intel each year. The next example is an example on how we are testing a component of our CPU and actually the visual processor of Intel. And the idea here was to replace the manual verification process that aims to identify corruptions when streaming videos in games. The way that it was done in the past, so there were lab technicians that their role was to sit and to watch YouTube videos, play games, and with the objective to identify video corruptions. Maybe for some of you it sounds interesting, but it's actually a very manual process that is very time consuming. And most importantly, things are being missed. Our eye cannot always catch all of the different corruptions. So the idea was to replace that with a fully automated AI-based system where cameras are actually watching and identifying the corruptions. So what we have done is the first step was to actually generate data sets. So we needed to train them. In order to train the items, we needed to select videos that some of them are with corruptions. So the algorithms will know to identify what is a good video or a good frame versus a corrupted one. So one of the efforts was just to generate some data sets in order to be able to provide with good and bad examples. The next challenge was to build the deep learning models. And if you remember at the beginning of the presentation, I talked about the fact that the deep learning models are they outperform when we're talking about videos as an input. So the machine learning algorithms were trained in order to identify corruptions that are included in the datasets, but also to be able to handle new corruptions that are not necessarily been synthesized in the dataset that was given as an input. Last but not least, as challenging as the training of the algorithm was, another challenge was to develop an inference system that will integrate into the lab and will be able to identify in millions of frames that in near real time, being able to apply the deep learning model and understand if there is a corruption or not. And this is a very complex system that we needed to develop in order to apply the deep learning models. So this is another example on how an AI project or an AI application can actually replace some manual work and actually do a better job than the one that is being done previously. The next example is an example of how our Intel's CPU is actually using machine learning and AI. And this is a capability that was released in the latest Intel generation that was released to the market last year. And here, the idea is how AI can improve Intel's products by providing more power and performance from a user experience perspective. And what we have done here is the ability for the machine learning algorithm to predict what is the workload that is currently running on the computer. And I can tell you that is not a very easy task. In every second to understand what is the workload that is currently running and what will be the next workload, in order to understand whether the machine needs to go into a turbo mode, and if going into a turbo mode, what is the level that will maximize the user experience. And user experience meaning that the performance will be as maximum as possible, but at the same time without impacting our power and battery. So this is an example on how we can use machine learning in order to predict what is going to happen in the next few seconds in our computer, and based on that, adjust it accordingly so the user will get the maximum performance. The last example for today is going back to our manufacturing area. And this is an example for being able to identify that a certain machine or a certain robot in our factory is actually malfunctioning. And here we are using our data is some sensors that are placed on those machines. And those sensors are accelerometers. And what we have tried to do is to identify anomalous behavior in order to understand if that system requires some maintenance, in order to be able to ensure that it won't affect the goods that that machine is currently manufacturing. One of the problems is to identify it too late once we already have some defects, and it's after the fact. So the idea is to be able to identify it as early as possible, perform the maintenance or understand what is the problem with the machine, fix it, and then making sure it won't affect production yield. So you can see here in the two graphs that are presented, one graph, the upper graph is representing the normal behavior, where the lower one is a bad behavior. And you can see that in two places there are some spikes, but in one case it's abnormal behavior, where in another case it could be that it's perfectly normal to have that spike. So the machine learning algorithm need to understand exactly what is the norm, and with different cases, and be able to detect what is the anomalous behavior with minimal noises and false negative mistakes. Moving to the last section of the tutorial today, in which I would like to give some, perhaps some tools and best practices for those of you who would like to start building AI organizations or starting to deploy some AI projects. So a few practices that we have developed over the years and we are using when starting new projects. The first one is how to identify an AI project or an AI use case. So a few criteria I would like to call out. The first one is the decisions are data-driven, meaning that if you have a business process where there are different considerations that your data cannot explain why a certain decision was made, even if it's a complex one, but there is the data that knows to describe it. So it won't be, no machine learning algorithms would be able to mimic the underlying logic. So whenever we are selecting an AI use case, that means that decisions are being driven by data. The next one is that history matters, meaning that the history can predict on what's going to happen. It's not meaning that that nothing will change, but it means that if we will look, I don't know, 1 day before, 2 weeks before, looking on the data can indicate on what's going to happen. The next one is talks about the ROI, return of investment. If you can solve it manually, or if the current solution is a good one, it doesn't mean necessarily that you need an AI. AI is good for cases where problems, it's infeasible to solve it manually or using other tools. And the reason that I'm calling that out, that obviously AI requires some advanced skills. We'll talk about that in a minute. There are some risks, and it's not always feasible. So we need to make sure that AI is required, and it's not just because it's cool or it's new technology, but it's actually required. So assuming that you would like to assess what is the feasibility before starting a new project to have a go, no go decision. So here is a partial checklist that I would recommend to follow in order to assess what is the feasibility for a project to succeed. The first one, is talking about the business feasibility. We need to make sure that the problem is clear, what exactly we are trying to solve or what we are trying to optimize. The second thing is that, as I said, AI is all about being able to operate in an autonomous way in a scale. Meaning that we are going to change business processes. We are going to change the way people are working. And when we're talking about changes, obviously not something that is easy. And there needs to be a willingness to change. We need to have an endorsement of our management for the change. And that is very important thing. The more intrusive your use case is, the change will be higher, and this is something that you need to take into consideration. Last but not least, as I said, an AI project has a price on it. It requires skilled people. It requires sometimes high investment. You need to be able to quantify what is the ROI or the business value, the impact that you're going to achieve once you have this capability in place. So this is the business aspect. From a data aspect, and we talked about data a lot today, so we need to make sure that our data is accurate. We have sufficient data that is properly explain the problem that we are trying to solve. And also, we have access to the data. Working in an enterprise sometimes, and we don't have all of access to all of the data. Sometimes the data is not connected. So we need to make sure that we have everything we need from a data perspective in order to feed our algorithms. Last but not least is the execution. AI technologies needs to be introduced into the environment. You need to make sure that you have the ability to deploy them, to execute them in a timely manner from a size perspective, and you have the required IO. As I said, that the training phase can be quite heavy. So you need to make sure that you have all of the resources that you need in order to be able to execute it at scale in production, and of course to maintain it over time. During the last few slides, I talked about the skills that are required in order to build an AI project. And many times we're thinking of, well, we need data scientists. So a data scientist, of course, are very important, but is only one type of skills that we need in order to assemble an AI project team. Since we are, when we're talking about an enterprise and being able to implement use cases, we need to have a very good, an excellent understanding on the domain that we are operating in. So we need people that understand the business aspect on how and understand the domain, the specific domain in which we are operating. And those people must be part of the project team. In addition to that, we need software engineers, machine learning engineers that knows to productize the machine learning algorithms to be able to run at scale in production with the right resources at our disposal, and also be able to handle all of the big data technologies that we talked about, and these are the machine learning engineers. Last but not least, there are the product managers that knows to orchestrate all of those different functions, being able to articulate what are the business requirements, how the project is going to be implemented, being able to talk the talk with all of the different players, and these are the AI product managers. So this is our last slide for today, and these are a few recommendations on some best practices that we've defined over the years that we believe that are increasing the likelihood for an AI project to be a successful one. So if you're starting to practice an AI, first of all, learn the industry methodologies, like any software project, Agile, Scrum, etc. There are some well-known methodologies. Christian is one of them, but make sure that we are following a well-known methodology. The right way to go is to start with some POC, proof of concept, and being key performance indicators, measure them on your POC, and use those same KPIs later on in production to make sure that you're actually meeting the goals and you are seeing the ROI that you have expected. The next one is the data. We talked about so much about the data. So this is the fundamental for any AI project, and you need to invest enough time in your data, either to generate it if it doesn't exist, or to model it properly so it can feed the model. The AI project itself, there is always a trade-off on which algorithm to use. Sometimes it could be a very simple one, but it won't be robust enough. And sometimes the too complex will not meet the resources that you have at your disposal. So it's an art to balance between the keep it simple and the robustness of the algorithm, and this is the art of data science. I talked about the proof of concept, but this is the first step. In order to productize it, there is a long way to go, and this is essentially at the end of the day to realize the ROI, but that needs to factor into account when it's model. It's not just have a successful POC. Sometimes you need to develop an AI platform that knows to apply and retrain those models on a certain cadence, and that takes time and requires knowledge. Last but not least, AI in many cases is when implementing it as part of a business process, it requires to redesign the business process. As I said, it requires change, and you need to be working with the right individuals in order to redesign how a certain business process is going to work with an AI component inside of it. And this is a fundamental for a success and for realizing the potential ROI for the project. So it's critical to invest and to take that into consideration and partner with the right people in order to achieve that. And with that said, I would like to thank you all and to open up for questions. Thank you very much.
Hi, this is Chen. I'd be happy to answer any question. If one's, please raise your hand or write it in the chat, or please speak now. So we have one question. Can you give an indication how big Intel's AI unit is currently? Yes, of course. So we are at Intel about 200 employees. All of them are specializing in AI in the different profiles that I was talking about in the presentation. We are working across the company. You can see the examples that are very diverse. So the organization is relatively large in compared to other companies. However, this is something that was grown over the years. We started with a few dozens of AI employees roughly 12 years ago. And as our impact, importance to the company increased, the organization got bigger as a result. So my personal take on that is to start small, demonstrate the value, and build based on that. Yes, I see that Tudor Timmy raised the hand, so go ahead.
But how many people do you need for such a project? Because like as you presented, it doesn't really sound like this is something that someone can just do by themselves or with just another colleague in their spare time. You need someone who does just this, right?
That's correct. Usually, the majority of the projects that I've presented, in average, we are talking about between teams of roughly 5 people. But the examples that I shown here are more complex one. Obviously, there are different level of complexity for different AI-related use cases. But if you want to solve a critical problem And it's just not just building the model itself, but also be able to productize it and to build the inference around it, making sure that that you're maintaining it over time, retraining, etc. So it does require a team of people in order to accomplish that. But we're not talking about teams that are too big. In average, a project is taking between 4 to 5 people, with the average of 6 months for a project with a complexity of medium and above.
Can I ask another follow-up question?
Of course.
Afterwards, how much maintenance is involved, and who does the maintenance in your? Does your team continue with maintaining the thing, or?
So our organization invested a lot in building automatic capabilities in order to minimize the support. And so the majority of the processes are completely automated, meaning that we have the ability to identify when the algorithms performance are degraded, being able to apply automatically a retrain of the model and publish the new model. So in order to minimize the support, and also this is not just the manual work consideration, also since we are impacting some of the most critical processes in the companies, we need to be able to react to those changes almost immediately. So in order to be able to support hundreds of models in production, we invested in automation and being able to do that almost completely in automatic way. Our team also, in cases where from time to time, perhaps you need to refine the model and to do some tweaks. So it continues to be performed by our organization, with a few exceptions that sometimes it's being handed off to the business, but in the majority of the cases that I've presented, it's being handled by the central organization.
Okay, so that was my follow-up question. So do you hand it off or do you keep it? So you say that most of the times you keep it.
Yes.
Well, you don't hand it off to the.
Yes. When we are talking about solutions or projects that are heavily that are complex and require skills that only exist in the central organization, in most cases it doesn't make sense to hand it off. But we do work hand to hand with the different engineering teams across the company, since as I explained, in many cases, the models are being embedded into the processes in the various groups and business units. So there is here a full partnership and working hand to hand. So it does change from one case to another.
Okay, thank you.
Another question, can you please briefly describe the challenges in implementing an AI algorithm in hardware? So a few things. I think that one of the key, I would say 2 key challenges. The first one is the amount of data that is available in every given moment is not huge. And therefore, your algorithm needs to be very sophisticated in order to be able to predict. Also, the time window in which the prediction is relevant is very short. So you don't have a lot of information, and you still need to be able to generate a prediction that can bring value. This is one thing. The second thing is obviously the real estate. You cannot implement a model that will consume a lot of resources. So you are limited in some of the algorithms that you can implement, the amount of memory or other resources that are required. Some of the algorithms are more complex than others and requires much more resources in order to perform the inference. So a lot of the challenges is to be able to shrink the algorithms to a size where you can actually implement it in hardware and still bring the value. So I would say that these are the most 2 the biggest challenges in hardware. Of course, there are a lot more. When the algorithms are being designed, it's in early stages, and later on, once it's implemented in silicon, perhaps you start to see a different behavior, and you need to retrain the model. So there are lots of challenges when implementing in hardware. I would say that these are the most challenging ones. Any additional questions? Okay, thank you very much.